Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 54. This lesson is all about any way you slice it. We will be learning about the area for a sector of a circle, a segment of a circle, and an annulus. First, let's match some definitions. So looking at the pictures, which one is the region between two radii of a circle and the included arc? The annulus looks like the entire circle. The segment is not between two radii, so the sector is between two radii and the included arc. Which picture is the region between two concentric circles? Remember that concentric circles are circles that share the same center. So the annulus is the region between two concentric circles. And our last one is the region between a chord of a circle and the included arc. We can see that the segment has a chord on one side and the arc on the other. Now let's figure out the formulas. The formula for area of a sector of a circle. Here we have the picture of a sector right in here. So we notice that it's part of the whole area, and what part of the whole area is it? Well, it's the part that is this measure out of the whole circle. So we have A, the measure of the arc, out of 360. So that's going to give us the fraction of the circle that we have. So A over 360 is the fraction of the circle we have. The fraction times the entire circle's area, which is pi r squared, will give us the area of the sector. So the sector is just one fraction of the circle. What fraction is it? Well, it is the part of the arc over the whole circle, which would be 360. What about the formula for the area of a segment of a circle? This one at first seems very difficult, but if we look at it as a sector minus this triangle up there, then that will give us the segment part. So we just did the area of a sector. It's the fraction of the arc measure over 360 times the area of the entire circle. That's the sector. Now we're going to subtract the triangle. So we see in the picture the triangle has a base and a height, so 1/2 base times height, and that is the area of the segment. So the area of the sector, which is the fraction of the circle times the area of the whole circle, minus that triangle, 1/2 base times height, is the area of the segment of a circle. What about the annulus? Well, we just have two circles. We need to subtract the smaller inside circle from the outside circle. So if we took this whole circle and subtracted this part, we would have the shaded blue region. So pi r squared with the big R, because that's the outside circle, minus pi r squared with a little r, meaning the inside circle, is the area of the annulus. Let's use these formulas on some examples. Let's find the area of the shaded sector here. So again, our formula for a sector would be the fraction of the circle that's highlighted, and that fraction is going to come from the arc measure of 60 degrees over the entire circle, which would be 360 degrees. So that is the fraction of the circle, and then we have pi r squared, r being 8 centimeters. So the area of this sector, 60 degrees divided by 360 degrees, is going to be 6 over 36, also known as 1/6. And then we'll have pi, and 64 is what 8 is squared, and it's centimeters squared. So then we can multiply 64 times 1/6, or 64 over 6. I'm going to leave it in terms of pi, and it'll be centimeters squared. This is our area. And we can reduce that fraction just a little bit to say that it's 32 thirds pi centimeters squared. Now remember, if you needed an exact number, you could divide this out and get a decimal and then multiply it by 3.14, but it is most exact to leave it in a fraction times pi. What about the area of the shaded segment? Remember that the segment is the area of the sector. In this case, we have 90 degrees. 90 degrees is that central angle, so that is also the arc measure. So 90 degrees over 360 degrees. You also might realize that this is one corner, or 1/4 of the circle. So if you wanted to go ahead and reduce that fraction to 1/4, 90 over 360 is the same as 1/4. Now the area of the entire circle, because we have a fraction of it times the whole thing, well, times the area of a circle, will give us the area of that sector. So that would be pi r squared. R is 12 centimeters. And then we have to subtract that triangle in here. And how do we know what that triangle is? Well, this could be the base, and this could be the height. And we know that this is 12 centimeters. What is the base? Well, this 12 centimeters is a radius of the circle. This is another radius. So they're the same measurement of 12 centimeters. Therefore, that triangle is 1/2 base of 12 centimeters times the height of 12 centimeters. So all of this is the area of the segment. So again, we said that 90 over 360 is 1/4. 12 centimeters squared would be 144, and we'll tack that pi on to centimeters squared. And then we're going to say 12 centimeters times 12 centimeters is another 144 times 1/2. Half of 144 is 72 centimeters squared. I'm going to take 144 and multiply it by 1/4. So 144 over 1/4 pi minus 72, and all of that is centimeters squared. 144 over 4 is 36 pi minus 72 centimeters squared. This would be our most exact answer. If you wanted to be able to combine these, you could estimate at using 3.14 for pi. 3.14 times 36 minus 72 is about 41.1 centimeters squared. One more example today. Find the arc measure if the area of the shaded region is 10 pi inches squared. Okay, so our area of this is a sector, and the area of a sector is the arc measure over 360 times pi r squared. We are given the area in this case, so that's 10 pi inches squared. We don't know the arc measure, but we do know R. R is 6 inches. So we're just going to work this algebraically. We have 10 pi inches squared on one side is this fraction. And then on the inside, I'm going to square 6 inches, and that's 36 inches squared. And I'm going to put that pi next to it, so 36 pi inches squared. I'm going to go ahead and divide by pi and get rid of that on both sides. And as the same way that we can get rid of pi, because pi is just a number, we could also get rid of our inches squared. Both sides has inches squared. So you can kind of just divide that out. Now I have that 10 is equal to A over 360 times 36. If I multiply 36 times A, I can reduce this fraction a little bit. So 36A over 360. I reduce that fraction to A over 10. It's going to leave me with a factor of 10 at the bottom. So that fraction is reduced to A over 10. So now I have that 10 is equal to A over 10. To solve for A, I'm going to multiply by the denominator, or I'm going to multiply because this is divided. On the left side, I have 100. On the right, I have that is A. So the arc measure is 100 degrees.